Last lesson, we learned the linear equation. Algebraically, we called it linear because a linear equation is found in the form ax plus b, where a and b are constants and x is a variable raised to the first power. We are now going to move one step further. In our linear equation, we have two terms, ax and b. Any linear equation can be simplified to that form. The next equation is a quadratic equation, and it has three terms. Let's look at the definition of it, and we'll talk about it. Definition of a quadratic equation. A quadratic equation in X is an equation that can be written in the standard quadratic form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. We can first notice that the two second terms, bx plus c, looks exactly like our linear equation. With the addition of the x squared term, our equation becomes a quadratic. As a memory help, the word quadratic comes from the Latin word quadrare, which is where the English quad, meaning 4, comes from. Geometrically, it takes 4 equal sides to make a square, and if you remember geometry, the area of a square is given as a formula by x squared. While the quadratic equation does not make a square on a graph, it does include a squared variable. Thus, we call them quadratics. The goal of this chapter is solving quadratic equations. We want to find the values of x that make these equations true. Unlike linear equations, there are several methods to solve these quadratics. They are not generally difficult, but we do need to be mindful that we'll end up with two solutions after solving a quadratic. There's a simple reason if we look at the left side of our quadratic equation. Recall back when we were looking at the prerequisites for algebra, we learned how to factor degree 2 polynomials. A degree 2 polynomial is actually a quadratic expression, so we already know how to factor quadratic equations. The only difference here is that our expression is set to equal 0. There's a common principle that can help us solve for x. The zero product principle. If a and b are algebraic expressions, such as a times b equals 0, then a equals 0 or b equals 0. What the zero product principle is telling us is that if we have a product of two expressions, such as how a factored trinomial becomes a product of two binomials set to equal 0, then one of the expressions must equal 0, since any number multiplied by 0 is equal to 0. Let's look at the quadratic equation x squared minus x minus 6 equals 0, where a equals 1, b equals -1, and c equals -6. When we factor the left side, it becomes x minus 3 times x plus 2 equals 0. So we know now that either x minus 3 equals 0 or x plus 2 equals 0. Solving each expression for x, we get the solutions x equals 3 and x equals -2. And that's it. We have solved this quadratic equation. Even though every quadratic will produce two solutions, some equations will produce the same value for x for each solution. For example, x squared plus 4x plus 4 equals 0 becomes x plus 2 times x plus 2 equals 0, which gives x equals -2 and x equals -2 as our solutions. This is called a double root Let's practice with a few examples. Number 1. X squared plus 8x plus 15 equals 0. We have a simple quadratic equation similar to the one we just solved. Let's factor the left-hand side first. X plus 3 times x plus 5 equals 0. Now solving each expression for x, we get x equals negative 3 and x equals negative 5. Notice that this time around, we got two negative solutions, showing that it's possible to get any combination of signage in our solutions. If you wanted to, you can plug your solutions back into the quadratic equation to see if we get 0. Using x equals negative 3, we get negative 3 squared plus 8 times negative 3 plus 15 equals 9 minus 24 plus 15 equals 24 minus 24, which equals 0. You can check each solution personally if you'd like. It helps understanding the logic and processes discovered in the algebra. Number 2. 2x squared minus 16x plus 14 equals 0. This time around, we have a constant a term on our quadratic. While it's definitely possible to factor right now, it's much easier if we divide the entire equation by 2 so that we can have an easier time with our algebra. X squared minus 8x plus 7 equals 0. Factoring this trinomial, we get x minus 1 times x minus 7 equals 0. Solving for x, we get our solutions of x equals 1 and x equals 7. Number 3. 3x squared minus 5x equals 0. Notice that we now have a quadratic equation without a c term. We can still work with this. If we factor out one of the x's, we will still arrive at the a times b equals 0 pattern. X times 3x minus 5 equals 0. Solving the second expression for x, we get x equals 5 over 3. Thus our solutions are x equals 0 and x equals 5 over 3. Number 4. X squared equals 7x minus 12. If we get a quadratic equation that's not in standard form, we could try to put it into standard form by putting all terms on one side and setting it equal to 0. X squared minus 7x plus 12 equals 0. And we can now factor it in this form. X minus 3 times x minus 4 equals 0. Finally solving for x, we get x equals 3 and x equals 4. Number 5. X plus 4 squared minus 9 equals 0. We might think that at this point we no longer have a quadratic equation. However, notice that we can expand that squared binomial into a trinomial. X squared plus 8x plus 16 minus 9 equals 0, which simplifies to x squared plus 8x plus 7 equals 0. This can be factored as x plus 1 times x plus 7 equals 0, which gives us the solutions x equals negative 1 and x equals negative 7. Quadratic equations are extremely useful and common throughout the sciences. Being proficient in the sciences and maths will require us to become skilled in solving these types of equations. While these here were simple enough to solve, there are times when more difficult ones will require tools to aid us. The next few sections will involve looking at what tools can be used in solving aids to these quadratic equations. The next lesson will involve us using square roots to solve them.